All right, let's jump straight into this explainer. Today, we're looking at the trillion-dollar infrastructure that's literally required to scale up digital societies. We're witnessing a fundamental shift in how human coordination actually happens, and we're going to unpack exactly how programmable, automated systems are replacing outdated legacy frameworks. It's not just some abstract theory either. It's a fascinating, fully executable blueprint for the future of global economies. So if you've been wondering how the next era of digital interaction is actually getting built on the ground, you are in exactly the right place. Here's the blueprint we'll be following today. We'll start with the network state chasm. Look at synthesizing two kinds of law. Dive into smart contracts and empirical code. Examine insurance-backed polycentric law. And finally, wrap up by building out the Ricardian freeway.
Section 1. The network state chasm. We're going to launch right into the new demographic reality of our world, and honestly, the staggering ambition of these network states.
Just look at this dashboard data for a second. The population and annual income of network states are now rivaling major global cities like Tokyo and Mumbai. We're talking about a population pushing 1.7 million and an annual income of nearly $158 billion. These are absolutely no longer fringe internet communities or niche message boards. They have the massive economic gravity of a traditional nation, proving that empirical demographics are effectively replacing geographic borders. We are seeing a complete reshaping of how human capital organizes itself, replacing arbitrary lines on a map with cryptographically secured opt-in digital societies.
And because of this massive shift, traditional nation-states are now aggressively competing to attract this sovereign, highly skilled talent to their own jurisdictions. Countries are actively modifying their tax laws and regulations because they clearly recognize that the sovereign individual is a highly mobile, highly lucrative demographic. Yet despite this immense wealth and global talent pool, no single network state has found long-term mainstream sustainability just yet. The early adopters are totally on board for sure, but the broader mainstream is still extremely hesitant.
And that brings us to the core problem. They're hitting a massive structural roadblock known as the chasm in the adoption curve. This illustrates the exact friction point preventing network states from achieving mainstream sustainability. They're basically stuck right in that gap between the visionary sandboxes and the early majority pragmatists. The innovators and techies have proven the concept works in isolated pockets, right? But scaling it to the broader, risk-averse public, the pragmatists, requires an entirely different level of trust. The current legal and regulatory friction is simply way too high.
So how do they get past this? Well, to bypass this chasm and achieve widespread adoption, they need a beachhead strategy. And that strategy takes the form of hard, programmable legal engineering. Think of this as the essential bridge. Mainstream pragmatists demand absolute certainty, speed, and safety before committing their capital. By turning ambiguous traditional law into predictable, machine-executable code, legal engineering provides the exact foundation needed to confidently cross that chasm. It gives those pragmatists the undeniable mathematical certainty they demand.
Section 2. Synthesizing two kinds of law. The crucial point here is understanding the actual practical blueprint required to build this new legal ecosystem. How do you actually program a society's rules?
Well, we literally have to deconstruct traditional, subjective legal doctrines and completely rebuild them into an applied, empirical system of interaction. You know, it's really no accident that we use the word law for both the laws of physics and the laws of society. Legal engineering takes the strict predictive accuracy of scientific law and synthesizes it with the messy, complex reality of human relationships. We're trying to blend the undeniable truth of a mathematical equation with the nuanced understanding of a handshake agreement to create a totally new operating system.
By bridging the predictive certainty of scientific law with the social dynamics of legal law, engineers are creating a highly reliable foundation that digital pragmatists can actually trust. On one hand, you have strict, empirical facts, logic that executes exactly the same way every single time, without bias or fatigue. On the other hand, you have fairness, equity, and human trust. Legal engineering merges these together. It ensures that when you enter an agreement in a digital economy, the execution is mathematically guaranteed, but the parameters still reflect a fair, mutually understood meeting of the minds.
Section 3, Smart Contracts and Empirical Code. Let's move into this next part and see how this builds upon a deeply pragmatic, historical pedigree that's actually been evolving for hundreds of years. You see, this engineering isn't just some sudden theoretical novelty. It's the fascinating story of taking wet, subjective human language and steadily engineering it into dry, objective, machine-executable code. Way back in the 1630s, Pierre de Fermat, who was actually a professional lawyer, used judicial pragmatism to formulate early calculus by intentionally ignoring microscopic errors. Fast forward to 1969, Charles Goldfarb, a Harvard law grad, invents markup language at IBM to standardize complex legal documents. And then, in 1996, Nick Szabo maps common law doctrines directly onto network protocols, giving birth to the modern smart contract.
And the impact of this evolution is absolutely staggering. Translating contract law into network protocols has a causal, direct relationship to creating over $20.5 trillion in the modern digital economy. By taking the friction out of human agreements and allowing servers to communicate through precise languages, legal engineering effectively built the foundational infrastructure of the internet. This is an abstract theory. It is the literal architecture currently underpinning over 17% of global GDP.
Section 4, Insurance-Backed Polycentric Law. Now, if we want to capture the next $20 trillion, we have to look at the physical testing grounds making this possible today.
In network state sandboxes like Prospera down in Honduras, companies are using polycentric law to literally choose their own regulations, moving far faster than traditional legal systems ever could. Polycentric law basically means choosing your regulatory framework from a marketplace of competing providers, rather than being stuck with a slow, one-size-fits-all government monopoly. If you want to test a cutting-edge AI, you don't have to wait years for bureaucratic approval. You effectively opt into the framework that best fits your business, entirely bypassing decades of backlog.
And here's how they make it safe for the mainstream. Through what's known as the Tortfeasor test, economic safety is automated because private insurance providers, rather than slow bureaucrats, evaluate the risk. Think about it. Instead of waiting for a government agency, an insurance company evaluates your new AI agent. If they're willing to financially back the risk, you're good to deploy. We test it empirically in the real world. Once that AI demonstrates a perfect safety record, that track record crystallizes into a guaranteed, codified safe harbor law. Safety is driven by actual market data, not red tape.
Section 5. Building the Ricardian Freeway. Finally, let's examine the ultimate infrastructure output required to scale these digital economies to their full potential.
Global commerce today moves at the speed of machines. Decentralized autonomous organizations absolutely need an environment designed specifically to scale from animal brain to machine brain coordination speed in order to cross the chasm. This requires building what we call Ricardian freeways. Protocols like Kleros and advanced smart contracts act as this new high-speed highway, because when a digital business is moving at light speed, it simply cannot pull over for a 2-year traditional court dispute. It needs an ecosystem built natively for the digital realm, enabling instant, mathematically verifiable execution.
When legal engineering paves these highways, the core KPI is reached. Setting up complex legal relationships becomes as cheap and accessible as buying a hamburger. Right now, starting an international trust is a luxury reserved for the ultra-wealthy because manual legal labor is prohibitively expensive. But by mechanizing these processes, law transitions from a scarce, expensive luxury into an abundant, incredibly cheap utility. This programmable, insurance-backed highway is exactly what gives mainstream pragmatists the safe, affordable ecosystem they need to finally cross the chasm.
So I'm going to leave you with this to ponder. As network states cross the chasm on these automated, insurance-backed highways, how will legacy systems possibly keep up? Once global talent and capital fully realize they can operate in an environment where law is instant, mathematically secure, and incredibly cheap, well, the shift is going to be absolutely monumental. Thank you for joining me for this explainer. It really is just a fascinating time to watch this entire infrastructure being built right before our eyes.